In this video, we're going to be looking at vocabulary of lines. Specifically, we're going to be looking at different forms of equations that we might encounter. We're also going to talk about rate of change or slope, as we are probably more familiar with that term. And also, we're going to be looking at intercepts, not only the x and the y, but we're going to call them vertical and horizontal intercepts. This video is going to be in two parts. The first part of the video is going to talk about the different forms of the equations, and then we'll start looking at how do we actually pick out equations and graphs and match all that stuff up. Second part of the video, we'll look more at intercepts and also how to look at parallel and perpendicular lines. So some terminology before we do anything. We need to talk about the different forms of the equations of lines. And these are two of the main types: slope-intercept form and point-slope form. So the one on the left, slope-intercept form, is one that you're probably very familiar with. Probably seen it since like 6th grade, but we've got y equals mx plus b. And the m value is your slope, so that's your rate of change, how the vertical coordinate is going to change in relation to the horizontal coordinate. And then b is your vertical intercept. Normally a y-intercept, but we call it vertical intercept because the vertical axis isn't always y. It could change. It could be a w or something else. And then we have point-slope form. Same basic idea of we're trying to use this to help us either write the equation line or graph it. We have slope in there like we had before, but now instead of just the vertical intercept, we have a specific point laid out. X1 here and y1 here. And that's going to be a point that is part of the actual line. And there are two different special types of lines that we can look at. And really doesn't matter. There's no special form for them. They're just, they are what they are. The vertical line will always have the equation x equals, or whatever the horizontal axis is. If the horizontal axis is t, it's going to be t equals, and then some number. And that line is a line that's going to go straight up and down. So it's going to look something, if you have our axes like this, something like that. That's our vertical line. That slope is undefined. Versus a horizontal line, if we're in the standard xy plane, it's y equals something. But again, it's whatever a vertical coordinate equals a number, that's a horizontal line. And the slope is 0. And then slope is, we define that as the rate of change. It's how much the vertical coordinate, vertical change, changes in relation to the horizontal coordinate. We call something with a positive slope increasing. We call something with a negative slope decreasing. Again, they're interchangeable terms. We have to be very flexible and know what we're looking for. If it's looking for increasing, that's right, it's a positive slope that I'm looking for. And the vertical intercept is the value, so it's the number at which the graph crosses the vertical axis, whatever that happens to be. A lot of times it's y, but it could be really anything. Same thing with the horizontal intercept. It's the value at which the graph crosses the horizontal axis. Usually x, but it can be other things. So on a graph like this, as given the graph of the line to the right, we have the graph all laid out ready to go for us. So it's asking us to do a couple things and then put it together. And this is where it gets a little bit tricky because it's not just saying, hey, find the x-intercept. Great, got it. It's not saying, hey, find the slope. Okay, got it. It's asking you to say the value of the x-intercept is going to stand for p. The value of the slope is going to stand for n. And then once you find those two things, find p plus n, which just basically means add them up. So first let's look at the x-intercept. That's where it's going to cross the x-axis. And it's the value, and so that value occurs right here. That's where the graph crosses the x-axis. The x-coordinate there is -2. So p is -2. And then I've got to find the slope. So what I'm looking for is how much does the vertical coordinate change compared to the horizontal? Really what I'm looking for are two nice points that are very clear. And I know this one, that's a really good point because we've already used that as our x-intercept. The next point I'm going to use looks like 1, 2 would be a good one. So I want to know how much does this go up? Well, let's see, it goes up 2. And then how much does it go to the right? So 1, 2, 3, plus 3. Now I know it's a positive slope because it moves up and to the right versus down to the right. All right, so again, as we move left to right, that line is definitely going up. So my vertical change is 2, and my horizontal change is 3. So my slope is 2/3. So that's the value of n. I'm asked to add them together. Well, if I'm looking for fractions, I need to have a common denominator. So 2 would be the same thing as 6 over 3. And so putting those together gives me negative 4/3. So again, it's not just interpreting parts of a line, it's interpreting parts of a line and then doing something else with it. These are the types of questions the SAT likes to ask. All right, so now we get into a question, matching an equation with a graph, which should be pretty straightforward. In a lot of cases, we can start eliminating some choices right away. So again, it is a multiple choice question, so we're looking for the one that best fits what we're trying to find. Well, based on the fact that this is a graph that appears to have a negative slope, I believe I can get rid of immediately A. Oh, there it lets me draw now all of a sudden. A and B, because those have positive slopes. So now, at the worst, I'm 50-50. Now I've got basically just looking to figure out what would be the most appropriate answer. So it's going to go through the origin, which is nice. That point is 0, 0, so that works out really nice for me. But then I've got this point right here, which seems like another convenient point. So if I'm going from this leftmost point to the rightmost point, it looks like I'm going to drop 3, so minus 3, and then move over 2. So again, it's the vertical change over the horizontal change. So it's negative 3 divided by 2. It's got to be C because that's the only one that has negative 3/2 as the correct slope. I like this next one here because immediately we should recognize that that is a horizontal line. And so we should be looking for an equation that says something like y equals. And there isn't one. There's 3.5y equals, there's 3.5x equals, and then those other two choices down below. Well, I don't think that B or D make any sense here because there's no mention of y at all. And I know that my equation is going to have y equals if it's a horizontal line. So if I'm looking at my first one, if I'm trying to get y by itself, the way I would do that would be to actually divide by 3.5. Well, if I divide 0 by 3.5, I get 0. Well, y equals 0 is the x-axis, and that is not what's being graphed. So let me just double check and make sure that C is right. If I'm going to solve this, I want to bring that 3.5 over to the other side. And so I do get that y is 3.5. That's what I'm actually looking to find because I do have a y equals. So I think I got it. So C would be the correct answer. All right, now here's the trick on this one. We're looking to pick out the different parts. A few things stand out to me. If I'm looking at my equation, y is not by itself quite yet. It's almost there, but it's not quite there. The other thing too is I can possibly pick out the slope and the y-intercept fairly easily and then start eliminating some choices. But again, because y is not by itself, I actually need to get rid of that 4. And to get rid of that 4, I'm going to divide by 4 for all the pieces. And 2 of them should be pretty straightforward. If I take 4y divided by 4, that's y. Got it. If I take negative 8 divided by 4, I get negative 2. No problem there. What happens is when I'm dividing by 4, I'm effectively multiplying by 1 over 4. So when I take 2/3 times 1/4, I'm really going to get 2/12 x. Okay, so we generally reduce our fractions. I'm going to write that as 1/6. Now, from there, I can tell that my slope is going to be positive, so my graph will be increasing as I go left to right. And I can tell that my y-intercept will be negative 2. Well, immediately, I know that the correct answer has to be B. That's the only one that has an increasing graph, a positive slope, and a y-intercept of negative 2. Now, if I hadn't rearranged the equation to get rid of that 4, I probably would have accidentally picked choice D. So again, once you recognize it's not quite in the correct form, we do want to make sure that it is in the right form just to get the answer correct. Again, common SAT problem. All right. This is a really great question. So there's a lot of confusing things in here that we don't even really need to know. It says through the equation y equals ax plus b is graphed in the xy plane. Okay. If a and b are positive constants, which of the following could be the graph of y equals negative ax minus b? So what they're saying here is your original graph had a positive slope and a positive y-intercept. But the graph we're actually graphing is negative ax and negative b. So if a and b had been positive numbers, now all of a sudden those quantities are represented by negative numbers. Our slope is now zero, or I'm sorry, not zero, less than zero. Our slope is negative. B is a negative number now. Our y-intercept is a negative number. So I'm looking for any graph that is decreasing and has a negative y-intercept. And the only reasonable choice would be choice A. Again, without this being a multiple choice question, I really can't answer it because I'm really just trying to find which one could be the graph of the original function. So in this lesson, we looked at the different forms of the equations. We looked very briefly at intercepts. We're going to explore that more in depth in the next video. But we also looked at slope and how to match equations from graphs. In the second part, we're going to look at intercepts and then also the equations of parallel and perpendicular lines.